My dear students of the second preparatory second term, welcome in new episode. Today we are going to speak about sound reflections, the second lesson of Unit 2. Sound reflections. What is meant by sound reflections? Sound reflection, it is the rebounding of sound when it hits a reflecting surface. If we get a reflecting surface, for example, any surface, metal surface, and when the sound hit this surface and returns back, rebounding of sound to the same source in the same medium, this is called sound reflections. And there are many uses of the sound reflections, and there are laws of sound reflections. Let's study together. Sound reflection. Reflection of sound waves. Number one, dome of the rock in Palestine. Another picture. The big ears of gazelle help the gazelle to hear or to pick up a very weak sound in order to be careful to hide from their enemies. Imperio before birth can be observed also by the help of sound reflection. Sound reflection. You can observe this person when cutting grass. Sound produced from the grass cutter when it hits to the walls, it rebounding again. This is called sound reflection to the same directions. Verifying the laws of sound reflections. To verify the law of sound reflection, we are going to use a certain tools and materials. A wooden plate works as a reflecting surface, a table to put things on it, foam plate to work as an isolating plate which separate between two sides, two cardboard tubes opened from both sides. One of them contains a cell phone. Let's see together the table. Number two is the wooden plate and the foam plate. And here the other person try to help us to find the laws of sound. And two tubes, the first one with letter A and the second with letter B, and a cell phone in one of them. When it turns on, it produces sound, and the sound hits the reflecting surface, which is the wooden plate. The foam to isolate the sound from going to this person, and this person try to hear the best sound, and he moves the tube B to the right and to the left. He moves it to the right and to the left until it hears the best sound. At this point, he are going to remove the plates and so on. We get a wooden plate and put the wooden plate in a perpendicular on the table, perpendicular position. And the two cardboard cylinders opened from both sides. And one of them, which has letter A, contains a cell phone. When it is turned on, it produces sound. And sound is directed through the tube towards the wooden plate or the reflecting surface. When it hits the reflecting surface, it rebounding. And from the other side, I separate the sound by using a foam plate. I trying to hear the best sound by moving the movable tube, which can be moved. It is moved, but the first one is fixed. I fix it. When I hear the best sound, I remove all this. I remove the wooden plate, and I'll take a straight line. I remove the foam plate and I take a perpendicular line from point of incidence. I forget that you have to leave a certain space between the wooden plate and the foam plate, a certain space in order for the sound to pass through. If I close it, the sound cannot pass. I let a certain plate, and I consider this point at which the sound met with the reflecting surface is called the point of incidence, and receiving from the other side the reflected sound ray. By measuring the incident angle and the reflected incident angle and the reflected angle, yes, incident angle, it is the angle lies between incident ray and the normal or perpendicular line from point of incidence. Reflected angle, it is the angle lies between reflected ray and the normal. You observe that incident angle between incident ray and the normal. Reflected angle between reflected ray and normal. Normal is a common for both definitions, but in case of incident angle, it is incident ray. In case of reflected angle, it is a reflected ray. By observing between the two angles, it gives us an equal amount. The angle of incidence equal the angle of reflections. If we repeat and change the angle of incidence and try to hear the best sound from other side, you can observe that always, even if you make it 100 times, you can observe that always angle of incidence equal angle of reflection, and this was the first law of reflection. Angle of incidence equal angle of reflection. Let's turn back to the graphic. This is the reflecting surface, and this is the normal from point of incidence instead of the foam plate. And this is the incident tube letter A, the incident sound ray, and the yellow ray, it is the reflected sound ray, and X, it is the reflected angle, X yellow, and X red, it is the incident angle. They are equal. Incident angle equal reflected angle. And this was the first law of sound reflections. First law of reflections, angle of incidence equals angle of reflection. Second law of reflection, the incident sound ray, the reflected sound ray, and the normal to the reflecting surface at the point of incidence all lie in one plane perpendicular to the reflecting surface. In one plane perpendicular to the reflecting surface. If we said that this is the incident sound ray, this is the reflecting surface, and this is the incident sound ray, and this is the reflected sound ray, and the normal. The incident and the reflected and the normal are all in one plane, which is perpendicular to the reflecting surface. Incident sound ray, reflected sound ray, and the normal. The three of them are in one plane, which is perpendicular to the reflecting surface. This was the second law of sound reflection. Let's move to another point. When the sound ray is incident perpendicular to a reflecting surface, it reflects on itself, suffer no reflections, since angle of incidence equals angle of reflections and equals 0. This is a reflecting surface, and this is the incident ray is the green, and the reflecting ray is the yellow one. If the incident ray is perpendicular on the reflecting surface, angle of incidence equal angle of reflection equals 0. Since angle of incidence is the angle between incident ray and normal, and there is no angle between incident ray and normal, the incident ray is perpendicular, and so angle of incidence equals the angle of reflections equal 0, and the incident ray perpendicular on a reflecting surface suffers no reflection. Let's move to another point. Echo. What happens if you stand in a certain place and start to speak, and you hear the sound several times? The sound is repeated several times. You can say that it is echo. It is known as echo. This phenomena is known as echo. Echo, it is the repetition of sound due to its reflection. Due to its reflection. The repetition of sound due to its reflection. We are going to speak all the time, and we cannot observe any type of echo, master, because echo requires a certain conditions. From these conditions, number one, the presence of a huge reflecting surface. A mountain, for example, a huge building like a hotel, for example, this is considered a huge reflecting surface, number one. Number two, the distance between sound source and the reflecting surface not less than 17 meters. More than 17 meters, it is okay. Less than 17 meters, the human ear cannot distinguish these sound reflections. The distance not less than 17 meters, and the time between hearing or producing the sound and its echo not less than 1/10 seconds. 10th second. So the three factors required for presence of echo: number one, the presence of a huge reflecting surface; number two, the distance between the sound source and the reflecting surface not less than 17 meters; the time between sound and its echo not less than 1/10 seconds. Echo, it is the repetition of sound due to its reflection. echo. It is the repetition of sound due to its reflection. The Kibash corridor in Karnak temple. When you produce a sound, the sound is repeated several times, and you can, for example, if you say Ahmad, you can hear it Ahmad, Ahmad, Ahmad. It is repeated several times due to its reflection, and is called echo. Another example, conditions for hearing echo. Number one, presence of a wide and big reflecting surface such as walls. Number two, the distance between the sound source and its echo not less than 17 meters. Number three, time taken between hearing the original sound and its echo should not be less than 0.1 second. Determinations of the speed of sound in air. Calculating the velocity of sound in air. If we get a big screen and two pieces of wood, if we hit the two pieces of wood against each other, sound is produced and travels towards the big screen. And then it rebounding due to reflections and returns back. The blue one is the incident sound ray, and the red one is the reflected sound ray. The distance, you know the distance between the sound source and the reflecting surface. Also, you can, you know the time between the sound produced and the sound returns back, the time between them, or the time of echo. By knowing distance and the time, you can calculate the sound velocity. Since d equal v by t. But in this case, we calculated two times, the time going and time backwards, and you have to divide two. So v equal d divided half t. Let's move to another point, sound velocity. Twice the distance between the source and the reflector over the average time of the echo in seconds. Concentration of sound. Scientists observed that if you speak in a certain place, sound hit a huge reflecting surface and it reflects back and echo is occurred. Concentration of sound. Worship places, conference halls are built with concave walls and ceilings to increase sound clarity. Muslim scientists observed that when sound hits a concave surface, it can be collected, and they need this in prayer. And to make the voice of the Imam clear and concentrated, they build the mosques in a shape similar to a concave shape. When the sound is hit a concave surface, it can be reflected and collected in a certain point called focus of the voice. And in this point, sound intensity increase, and also you can observe the echo of sound and gives the Imam a beautiful, concentrated, clear sound. So for all the prayers to hear the Imam clearly. Let's move to another point. Determinations of sea depths and fish shoals. Determination of the sea depth. We have a ship on the surface, produces and a sonar, a device that produces ultrasonic waves, hydrophone to receive the sound or the reflected sound. Sonar produces ultrasonic waves which hit the bottom or the sea depth, seabed, and returns back to hydrophone to hear the sound produced. And he knows, the scientist knows the speed of sound or ultrasonic waves in water and also the time can measure the time between producing sound and receiving it. By knowing the time and knowing the speed, you can calculate the depth. D equal V by T divided 2 reflecting waves. Depth D equal wave velocity by echo time divided 2. V by T divided 2. We can calculate the depth of the seabed or the distance between any object. The dome of Al-Aqsa Mosque, it is a concave shape in order for reflecting and concentrating the sound. Incident sound ray can be reflected and collected in a certain point to increase the intensity of voice and make the sound clear. And Fennec fox has a huge ear, concave in shape, in order to collect sound of prey to hunt them or to hide from enemies. Detecting industrial defects by using alt echo phenomena. He has the scientist here, or has a certain device that produces ultrasonic waves and measure the intensity of reflections. And by observing the intensity of reflections, he can determine that this place has a defect in the railway track, for example, as the example we have here. Medical diagnosis, as in detecting the sex of the embryo and its health condition. These are factors affecting or factors used from determination of the sound reflections. Medical diagnosis to determine the sex of the baby, male or female, by producing ultrasonic waves and receiving them back again. It gives a certain diagram for the baby inside his mother's body. A bat catches an insect by the same way. The bat produces ultrasonic waves. When it hits any object, it returns back to the bat, and the bat can observe the place in which he can catch the prey. Many uses of ultrasonic waves, and at the same time the phenomena of echo. We observed that the phenomena of echo can be observed clearly and can be used in the determination of the depth of the sea bed, and also to determine the or used by the bats to locate the position, avoid the obstacles, and so on. This was the last thing today. I hope you enjoy with us. Until we meet again, I wish you all the best.